Hello, everybody. It's Christian Ludemann here, and today I'm here with Michael Hladky, and we're going to talk about Angular performance. Hello, Michael. How are you today?
Hello, I'm pretty good today. I'm very excited that we do that podcast, and I hope that we have a lot of interesting content today.
I'm sure we will. So, Michael, why don't you tell us a little bit about yourself?
My name is Michael Hladky. Hladky is very hard to spell, read, write, pronounce. I guess you can stick with Michael or with Michael in English. I run a company called Push-Based.io. We focus on performance and Angular architecture. And maybe some of you know me because I'm pretty active in speaking. I do a lot of consulting, a lot of public and private trainings, in-house trainings on Angular and on vanilla JavaScript performance. And yeah, this is most of the stuff that I do and my company serves.
Awesome. So in this episode today, we're going to go through a bunch of Angular performance points, and some of them are my points you already know about. Some of them are Angular specific, and some of them are some more like unknown secrets in the industry that we're going to unwind in this episode here. So the first point we have is Preconnect critical resources to speed up the initial resources fetch.
Yes, so Preconnect is basically a way where you can do a specific part of the work that you need for connect to a domain at an earlier point in time. So if you have 2-3 domains that you are sure you will definitely hit while the page bootstraps, you can pre-connect those HTTP requests, and you can basically move, as we can see here in that image, the connection time, the orange block at the very beginning, and parallelize those efforts. And later on, you can just focus on getting the data and not really spending time on some connection setup.
Yes. Yeah, you can share the screen if you want to share something. Okay, and then the second point is yeah, it's kind of related. I think it fits the same image. It's Preconnect critical URLs used in the bootstrap phase, or important URLs used later in time.
Exactly the same. So you can basically use that at your bootstrap time to speed up getting the required data, the data for the largest contentful paint, a little bit earlier. What you can save is the connection time. And if you have big projects, maybe some information from real life, if you have a lot of HTTP requests, and especially if you have many different domains, you can save quite a lot when introducing that stuff. The only trick that is maybe necessary here is that you find an automated generic way how you can add those small HTML snippets to your content, because sometimes a change and you don't want to pre-connect a domain that you don't want to use. It basically will also harm your Lighthouse score and definitely also your performance, because the time could be used for something else.
Have you found a way to automate this? For like getting the necessary, the critical URLs, having a way to like mark that maybe in the Angular routes and such?
Yeah, so in Angular projects, there is a way where I basically have a custom builder, and this custom builder, I guess you can also achieve that with only overwriting the HTML transform, index HTML transform. But we had a custom builder that helped us to have a configurable part in the Angular JSON as well as some dynamic stuff, and you would build the application for a specific route with everything that you need integrated. There were, of course, always some missing pieces, but in general, it worked out pretty good.
Now, I know you're doing a lot of open source as well. Is this something that's also available open source?
This part is not open source, as the builders are normally very clumsy to maintain, so and also very clumsy to write. And this is nothing that I guess is enough benefit for maintaining a custom builder. At the moment, not. Maybe in the future.
Makes sense. We can set up a shop. So how about step 3 is preload and prefetch immediate resource for the largest contentful paint.
Yes, we have preload and prefetch, and also the next part is then fetch priority. So now I will only focus on preload and prefetch, and it is about prioritizing important resources for your website in the page. For example, moving the page styles at an earlier point in time or at a later point in time, moving images at an earlier point in time. And you can preload, you should use the preload attribute to focus on stuff that will be visible on the page, maybe outside of the viewport, and you can prefetch stuff that you will reach with the next navigation. And this is more or less a priority that you can give to them. And if you add them at the very top of your page before anything else executes, of course, you cannot. You can also use them to preload, for example, some largest contentful paint, data, images, and so on at a higher priority.
Yes, and then also step point 4 is prioritize the resources with fetch priority, as we see in the
yes
tag.
So if you have a lot of this preloading ongoing, you have a hard time to prioritize things, especially if it is static information, there's not a lot that you can do. But recently, we received a new HTML attribute as well as a JavaScript option in the fetch API. It's called fetch priority. And here you can define the priority of this specific tag. So if you have two different preload tags after another, and one of them has a higher priority, but is later in the DOM, it will still get fetched earlier. And this is only possible at the moment in Chrome and Blink, Chrome and Edge. And a very powerful tool that can help you to, for example, optimize the LCP image drastically.
Nice. And step 5 is only include styles visible in the main bundle and move other imports directly into the respective component. For example, the button style.
So how to deal with that styles? Yes, in Angular, we are lucky because from the build, by default, we have the critical CSS rendered in the HTML. So what we see when we build an Angular application, we see inlined some CSS rules, and those are the CSS rules that apply to the stuff that is at the moment visible in the viewport. But you may want to also at some point load the rest of the styles, and then it is important that you don't overload with styles, that you only use styles that you still need. And if you have a lot of lazy loading going on and so on, you definitely want to splice or distribute the needed CSS on all the bundles and not have everything loaded at the very beginning. And this is quite a good technique, sometimes hard to implement because CSS is sometimes a mess in projects, so not really well organized, but in general a pretty interesting thing to do.
Nice. And step 6 is render only what is needed.
Render only what is needed is a quite interesting thing that you can do, and you can achieve that with different techniques. And with render only what is needed, I mean, focus on the stuff that is in the viewport and try to down prioritize the rest or avoid to spend work on the rest. And there are, let's say, JavaScript based things like visual scrolling and so on that they definitely target that stuff, but there are also modern APIs. For example, there is an API that is called content visibility. Let me quickly switch that in. So content visibility is this CSS attribute, and it's not super good supported, but still what it does, let me quickly theoretically explain to you. It has some benefits to the nodes that are visible, but now we talk about the stuff that is not visible. So for invisible for stuff outside of the viewport. It basically detaches those nodes, the off-screen nodes, from the browser render pipeline. So you can even skip recalculate styles for that node, and then you can drastically speed up your page. And here we see for the off-screen measurement compared to the real work, there is nearly nothing left. So from, let's say, 6 milliseconds paint, there is 0.1 millisecond paint left, and from 11 milliseconds of, for example, update layer tree, there is only a 61 microseconds left. So this is really a drastic, and I would call it brutal improvement that you can achieve by avoiding work for stuff that is not present at the moment on the page.
Is there any way to automate this, like finding out like what's above the fold and what's below the fold, and then?
Yes, so you can work, this feature, this CSS feature works with a couple of different mechanisms, and they have one thing that is called the viewport observer. And the viewport observer basically is also a JavaScript class that you can use that tells you if something is inside or outside of the viewport. And based on that, you can basically execute some JavaScript, load some data, render some nodes.
Mm-hmm. Yeah, the next one is lazy load images that are out of viewport to improve bootstrap metrics. It's kind of related.
It is related, definitely. I have here stuff too. So you will interact with the DOM. So you render the DOM, but you can basically save the HTTP request that is responsible to fill that DOM, that image tag, with some content or the iframe. And this attribute is called lazy loading, and you can put a value lazy there or eager, and then you can basically tell the browser what you should load and what you should definitely not load, what you should avoid to load if it is not visible in the viewport. It is
nice.
quite a cool feature. You can save a lot with that, and I can only recommend using that as much as possible, but also not overuse it. For example, you have to strictly avoid lazy loading LCP content. If you have the main hero image present, then you should not lazy load that one because it would down prioritize the HTTP request.
Yes, and also lazy load. Let's see, lazy load using slow lips is the next one, and then I don't think you actually mean like lips that are slow, but lips that can like lazy load things.
Yes. The last point is using the slow library. So avoid libraries that are big, clumsy, have a lot of code base, or have performance bottlenecks. And this is really the same page. I unfortunately don't have measures, but when I optimized the Angular Movies app, this is GitHub test.js Angular Movies, there is some PR open, available, one of the closed ones that talks about image lazy loading. Lazy, maybe we find stuff. And this PR, I will try 1-2 PRs now. Maybe I am lucky. Implement design system, remove, overload, test lazy loading route. It's not here, unfortunately. There was a really nice one where I found that a library that was used to implement loading lazy on images basically caused a recalculate styles when changing the DOM. So it was really slowing down the page. This was a performance bottleneck. So I deleted that library and used it manually. It was a drastic improvement. So I suggest if you do lazy loading, it's a minimum set of lines that you need to implement to have good lazy loading. I can quickly show it here in the code base. And there is a projects, movies, source. Yes, and here we go. There is the app. And in the app, there is, for example, the movie list in the UI folder component. At movie list, here we go. Okay. Inside of that component, we see that we have the index tracked by, and then on the image we say add the attribute loading. If it is the first image, don't add it. So add it always, but for the first image when the index is 0, and you can make greater than 2 or whatever, smaller than 2, and then you can enlarge it. For lists, it is quite good to do that, because you always have the first list item as largest content paint, first or second, depending on your page.
Yeah, but it's kind of the same point, like everything that's above the fold and it's visible. Then we want it to be loaded as fast as possible, and everything else can be lazy loaded.
Yes.
And then you also mentioned some libraries like Angular, SVG, and lazy image.
The lazy image, so there are a couple. Angular SVG is quite slow, and lazy images was also one that I found. But you know them, like there is also Moment.js that is pretty huge, some translation libraries. So all those things that you can explore with the bundle size analyzer are big, and all things that you see in a flame chart that are small from are making the app small, introducing bugs like the lazy loading thing, you should avoid. There is no official list of slow lips, but you most probably know them already when you Google about some performance bottlenecks and libraries. But those are one of them that I
would say I had some Angular performance jobs myself, and I think what's the most time consuming thing after you look at the bundle analysis tool is when you see, for example, they're using 2 or 3 different UI libraries, and then you're like, guys, you need to decide on one. Or they use Moment, and then you need to look at all these alternatives to the libraries they're using. That is what takes a lot of time. You also mentioned ngX. If you were to to cut down the bundle size for like a really critical site by changing the state management solution, that is actually what takes a lot of time, because now it's not just some quick tips. You're actually like changing the architecture and changing maybe tools that is everywhere in the application. And it's been like 5 years or 10 years in development that could take. then this optimization is going to take months.
Yes. So it always pays off to look for the estimated impact, and then you can suggest some low-hanging fruits first. So what I do in a performance audit, we run quite a lot of them, mostly on Angular applications, and we have a prioritized list on tickets that always tell you what will be the expected impact on kilobytes, milliseconds, whatever, and how time-consuming would it be to implement it, or how hard it is, and will it pay off? Are there enough users on that improvement? Those are like 3 parameters that we use to prioritize.
Yeah, but it comes very late in the development process. Usually around release, then they see that we actually have performance problem. The app
because
is slow as hell.
You don't continuously measure your performance, and this is a really cool thing that I'm working on at the moment. There is something that's called user flow, and user flow is basically enabling you to open the image to get such a measurement where you have the latest Lighthouse recordings. Like you now can not only do a navigation measure, you can also do a time span from here to here with some interactions in between and snapshots. And this is a programmatic measurement. So it is written in Puppeteer, and you can execute that also in the CLI. We have quite some interesting tickets open where we make some progress, and soon we will have it ready to be shipped in the CLI.
So this is running like Lighthouse?
It's the latest Lighthouse features combined with some Puppeteer scripts that you can run that in the CI. And I hope that I can find the respective image.
But yeah, you're definitely right. It's way cheaper to fix this early on and start looking at the button budgets and all this stuff rather than later on, because it's almost impossible later on. And you know,
definitely.
politics in big enterprises, you're not just gonna like spend months and rewriting and undo decisions. Then it's more like you're trying to hack yourself out of the situation because you're not just going to remove like big frameworks like ngX from the app, or if you use a bunch of CDK tools and UI tools, you're not just going to get rid of them if they're already used everywhere.
Or also, if you have very small and fast lips, you can mis-architect your stuff. And there's in the documentation also, of course, a section where we speak about budgets. So at a very advanced section here, we can have budgets from Lighthouse that tell you, I'm not sure if the quality is good enough, but you have basically a number of HTTP requests, a number of shipped bytes, a number of resource types, and you can narrow down and say, with bootstrapping this specific URL, I only want to have 3 HTTP requests, that's it. And if I change my architecture and then I fire 10, sometimes this happens, right? You just like do stuff and you have no clue what happens under the hood. Boom, this would catch it, and you can say it breaks the build or it will just inform you. And this is, I guess, a really nice feature that we always use and implement in our performance audits, and also in the development later on, right? When we suggest changes for a project, we also are able to implement this for them in a quite some quick way, because we do that all the time. So
it's super nice you share so many of your tools as open source on the GitHub page. It's cool that other people also can go and use the tools you're using like for your...
Pretty much everything we do, we try to do open source.
Nice. And yeah, then we're gonna jump to some more like runtime stuff. With the 9 point is use change detection strategy on push in all components to reduce change detection and template re-evaluation.
I have some slides here for that too, and Angular's component tree renders from bottom to top. Here I have a small animation, so it marks the component that is affected over a button click as dirty, and then a path up to the top, and this is what you see with the red triangles. And then in Angular, in default Angular application zone, Angular zone.js kicks in, and Angular re-renders the app by calling appref tick, and then everything is re-rendered. And this is of course bad. And if you turn on change detection on push everywhere, then you would not render everything. So everything that turned dark green now was re-rendered. You would, and this is over-rendered, right? So you only want to render the green stuff, but you have not rendered everything. It's not really good. And with OnPush, you basically, when you do the same mechanism, let me speed that up a little bit, you would only re-render this very specific path. So if you have input bindings that really change, it would re-render the component, or if it is dirty marked, and in this case it is dirty marked because of the button click. So you have this thing. It's of course not perfect, because if you look at the yellow color, this is again way too much that you render, and you really want to update only the green stuff. But this is what Angular serves by default. This is what everybody can just use without any additional code.
So, yes. Yeah. And then the next point is that you should avoid this top-down change detection.
Yes, you can avoid top-down change detection. You can focus on a specific technique. Let me scroll down a little bit, that we shipped with an open source library that's called RxAngular. And with RxAngular, we basically are able to render only one component. So if you click a button on this component, only this very component will get re-rendered. And in another step, I scroll a little bit more down, we already managed with structural directives. We can go even smaller, and then only the HTML that is marked with this structural directive will get updated, and the rest stays untouched. So this is avoiding completely the top-down rendering cycle that Angular has normally. And it is really a drastic performance impact when it comes to just default change detection. Of course, there is more. There's also a lot of scheduling techniques. inside, so you will never produce a blocking UI, for example, if you use that strategies here. But in general, it is about avoiding the top-down render cycles. And this is what you see here in comparison. Like on the left side, you have OnPush everywhere, and the async pipe. On the right side, you have our structural directive, and you see the thing is also happening without change detection on push, right? So you can have no change detection on push, change detection default. It would still only render this piece and nothing else. So this is a very independent. So whenever you use it, you can be sure you don't need to consider any other thing. You can just use it and be sure it will only render this stuff and not the rest.
Yeah, what do you do if it wants to render the child components?
Well, if you have child components and they have input bindings, so it goes from this component and downwards.
So
if you
it runs detect changes.
It runs detect changes basically, but not on the component level, only on the embedded view level. I can give you a little bit more info. So you have bindings and structural directives, and in structural directives like ngFor, ngIf, you have those small templates, and they are maintained in so-called embedded views. And in a embedded view, the class, you have also a method that is called detect changes. And this was the click for us when we realized we can go even smaller than component level change detection.
Nice one. And then, yeah, step 11 is disable zone.js as change detection system.
Yes, if you leverage a couple of our directives, and we have ngFor, ngIf, RxLet, the push pipe, and other things. We also provide component level change state management. Every component that uses no async pipe and one of our structural directives is already zoneless. So you can partially migrate to a zoneless application, and when you are fully done with migration, you can then disable zone. And here I just show how bad zone is. So it is not only shipping a lot of kilobytes, it is also having a lot of time spent on patching the APIs. If you would unpatch only parts of zone, this is doable with zone flags, another package that we ship with RxAngular. You can control which APIs are patched and which APIs are not patched. You see before and after measures, and here with Angular and zone flags and only 3 APIs, the set timeout, set interval, XHR, and scroll APIs unpatched, you would already gain very nice performance impacts.
How many milliseconds would you say you can save if you remove zone completely from a normal Angular app?
This is just an image, not really flame charts, but if you look at the blocking tasks here, they are all gone. So there is quite a lot to get. And if you look at the amount of blocking tasks, nearly every second task here is blocking, and here nearly no task is blocking. It is the same interaction. And you also can see like how big those scripting blocks are and how small those needles are here. So this is a huge comparison, a huge impact, I would say, not comparison.
So is this something you normally do for every Angular app, or is it only something you pull in when you need the heavy guns for the optimization?
As it is global, it's quite limited. So we, of course, try to disable whatever we can that is not really heavily used everywhere, but only at specific places. And we can also test it. But what you can do on top of it, you could also, as we said, go completely zoneless, and you then disable zone. You remove the import of zone.js, and this will give you a very quick app, because it is completely free of those randomly caused change detection triggers. You need local state management, of course, for that, and some directives that we ship to have a quick transition. If not, if you do all this or everything manually, you have, I guess, hard time to go zoneless.
Yeah.
And you, if you run detect changes manually without scheduling it in a smart way, you will also introduce a lot of performance bottlenecks.
Right. Yeah, and also like runtime throughout the app, it's you will see a lot of apps has like zone leaks where they have something like a timer running somewhere that's some event that just triggering like change detection top down all the time.
Yeah.
It can become for like third-party libraries can even no, but that's not connected to zone properly, so that probably wouldn't be a problem unless it's like it's triggered by Angular.
If you have any third-party library that uses one of those APIs, it will trigger change detection, and it will also influence, I guess, with at least the macrotask stable and so on. So you can have negative impact also, of course, from third-party libraries due to zone interference. That's definitely the case.
Have you seen many like problems with change detection not happening when you gone completely zoneless, especially like in a bigger enterprise app?
When we write an application or when we prepare an application that should go zoneless, we always use RxAngular, and there all the edge cases are covered. So whenever you move a directive at a specific point, that you trigger the change detection there. You also know that if you need the parent also to get triggered, that we also have a mechanism for this. You have a render callback that you can listen to. And you will not introduce blocking tasks, as we have a scheduling mechanism that is aware of the frame budget. But we have also other projects that we analyze and try to refactor, which is like a homemade zoneless application without our helpers. And there we often see quite some heavy performance degradations, because if you call detect changes everywhere synchronously, it adds up. So if you have frequently emitting things and other stuff, you over render a lot of your application with manual change detection when it is not rendered scheduled smartly.
Nice. Yeah, I think that's gonna be like it's a big game changer once, because it's been like it seems like a legacy tool almost from the beginning that Angular has to use this when other frameworks like React they didn't have this thing. They're way more precise and they're making like a big
they have
estimate.
an explicit state management.
Yeah, exactly. They just read up in some like more functional flow, and they know when the state changes, then it's time to render that particular component. And this this estimate of like maybe we should render now, so let's run the change detection every time some event has happened, and then maybe it's time to render. Step 12 is schedule app initialization into a new task to reduce total blocking time.
Yes, so especially so you have server-side rendering and everything, and then you still end up with this picture here where your bootstrapping takes a long time. And I have basically 3 small tricks that are listed here one after another, where I chunk up Angular's rendering. So here I identified 3 different areas that I can chunk up, and the first one is what you mentioned, the bootstrap time. So I want to separate those 2 things from each other, and I wrap basically Angular bootstrap module in a set timeout to chunk them up, and then I win 50 milliseconds of total blocking time, and this will increase the score a lot. Like total blocking time has 30% weight in your Lighthouse score, so this definitely is a good improvement, and you can save that with every new chunk that you introduce. Like this is the maximum that you can save with every new chunk that you introduce.
Yeah, but I'm wondering why the Angular team wouldn't make this the default when it bootstraps. If you give us this big of like this more interactive time.
It will maybe open up some window. The earlier interaction also means the earlier time where something else can kick in. Right, so if the browser has time and there is stuff, it will execute it. But I guess Angular was at the beginning not really focused on performance, and this is compared to other stuff that they can do, like inlining critical CSS, for example. It's minor and not really a big thing for them, I guess, to care about. It's this in combination with the other 2 questions that we have on the roadmap now is a good combination, I guess, but it's nothing that can be implemented by default. The next one in our list is basically about navigation. So the next question would be how we can schedule navigation, and it will also impact us in the same way. I will quickly go on with that question. We have in that next big chunk the initial navigation, and I can also disable navigation, and I can run the initial navigation in a set timeout in the next tick, and therefore I splice it out, as you can see here, and have another 50 milliseconds of less total blocking time.
And then the next one is schedule and prioritize rendering tasks.
Yeah. So the last one to split up is the app initializers, and then we have all the three of them. Let me quickly show the finished piece. So you have three pieces. This would be finishing up the previous one. The next question is schedule and prioritize render tasks, rendering tasks, and this is, I guess, already a super fancy thing. So imagine that you have the side menu and the list, and they would render nearly at the same time. So the browser would first spend time to render the irrelevant sidebar with the menus that is not really interesting for the user. And after that, it would prioritize the rendering of the images. And this has nothing to do with the HTTP requests from before. It is just the DOM, right? The DOM rendering of those items in the DOM structure, if you have already the data. And what we can do with RxAngular, we can basically prioritize tasks very easily. And this is the process that this runs. We schedule everything on a specific priority, then we prioritize that thing, and then we execute it in the right priority. And we have 6 different priorities here, or 5: immediate, user blocking, normal, low, and idle. They basically show you how important that stuff is for the user. This is visual user feedback is very high prioritized, and non-visual work irrelevant for the user is very low priority. And with this, you can achieve the right side here, where you first render the images and then later on render the side menu. And I guess this is a ultimately cutting edge feature, and you can implement that with, yes, 5 characters or less. Like, you only need to change the priority of the already existing structural directives. If you use RxAngular, there is rxlet and rxFor. Like ngFor, it is a 2-character replacement for ngFor. It also works with static arrays. And if you put a strategy on that, then you can also prioritize different parts in your application with a very little amount of changes. And normally, like, introducing this change here would cause a heavy refactoring of the application, because you need to rebuild the whole architecture, right? With our scheduling techniques, it is just some characters in the template. And this is, I guess, incredibly cool.
Yeah, I'm just curious, like, how does RxAngular then actually do the scheduling? Is it something like a set timeout, or like animation frame it's runs on?
It is a combination. So we wrote our own scheduler with Notion of the frame budget and other things, and then we found one that was created in cooperation with the React team, with Facebook and with the Chrome DevTools team. And this is a package, I guess, even in NPM. It's called Scheduler, and this scheduler provides us with all the features that we had. It is just a little bit more efficient than our custom written code. It helps us to prioritize tasks, and it helps us to not execute too much work in one tick. And it is really a game changer. Let me see if I have a good slideshow for you here, because we can concurrent mode, because we can really say, don't over render, don't execute if you don't have to. Let me move another slide deck in, and I'm searching for here it is. So this is what Angular would do normally, and blue is work. So it would just execute all the work in one piece, and then it would generate this huge task, right? And we chunked up the tasks before to have non-blocking interactions. And what our rendering can do, it knows how much of the frame budget is left, and then it would schedule automatically work pieces in the next task, so you never produce a frame drop.
And you said normally set the frame budget to like 50 milliseconds or something like that?
In our case, I guess it is set to 20-ish, 25-ish. I'm not sure if it's configurable, but it is pretty good from the results. You can, if you really need to change it, of course, change it in RxAngular, configure it, but out of the box, it works quite well. This is, for example, a comparison of ngFor versus rxFor. And as you can see, it is pretty amazing difference here.
A less blocking, clearly.
Yes.
Nice. And number 15 is fetch data included in main content on app initialization to reduce time of largest contentful paint, or LCP.
Yes. So imagine you have those two things, the list and the menu. And this time it is not about the DOM nodes, but it is about the data that you need to render the DOM nodes. The HTTP request that is required to fetch those two things. And here we see when they are fetched, right? Quite late in time when the movie list starts, and also here when the side menu starts. And what I suggest is you can use a factory in app initializer that kicks off those HTTP requests already derived from the URL, and then you can move and also shift and prioritize those HTTP requests very early on in your bootstrap phase. And then whenever you reach that component in the render tree, you don't need to wait and just fetch it when you want to render it, but you have it already when you want to render it. And especially the first fetch for the side menu here and also for the movie list is drastical. If you look at the milliseconds how you can render that earlier, it is really a nice improvement. And this is a very good internet connection. So imagine it on a mobile phone, it has even more drastical impact.
So this is something you combine with the other tips like pre-connecting the URL and preloading.
Yes, yeah, there's basically a set that we can implement many times, and some of them are like static informations, and you don't need to code Angular, and this is where you need to change a little bit of your architecture in Angular and implement the replay mechanism, of course.
Yeah. And then the next one is pass observables directly as inputs, which is also an interesting one.
It is definitely an interesting one. Let me quickly search for a quick explanation. So, yeah, this is what we normally do. We use the async pipe and pass the single value into my input binding. And this is like, if you try to do that over multiple layers in your components, you initialize dirty marking and change detection whenever you use the async pipe, and it is quite slow. And it is also independent of this, let's say, OnPush change detection, right? So if you could pass observables directly, and this is what we do here, we basically pass the observable as is in the input binding. We consume the value in the component input binding. We use a setter or a connect method from RxAngular to evaluate those streams. And we can also forward even more observables into child components. And at the very end, you end up rendering that with either the push pipe or the let directive. Let me scroll to the let directive. Yeah, this is the most performant one. And then you have like only rendered what's needed. So with this observable in the input binding, you open up a channel, and your change detection on push will never evaluate dirty, because the observable stays the same, but the values that you shoot through that channel, through the observable, the changes are different. And you can change now stuff independent of input binding dirty marking.
Is this only a benefit if you use RxAngular? Also, if you just use the async pipe, would this make a difference?
If you use the async pipe, and this is a very nice question, and this is what people many times forget. So even if you set up that at the end, at the very end, you will again use the async pipe. And what the async pipe is doing, it again dirty marks everything from bottom to top and renders top down as Angular would do normally. So the async pipe at the end is turning all the efforts again into crap. And therefore, we suggest really to use the push pipe, or in best case, the let directive, because it is really focusing on performance, and also ergonomic wise, it is way cooler to organize your view model with that principles, you can like replace them on multiple places in the app, in the component tree and template. So it's quite nice.
Yeah, by the way, what does the RxAngular do if the parent needs to be updated? Now it's using detect changes and it goes down, but also what about if it goes up?
So in very rare situations where the parent needs an update but is not receiving a new value. So when you need an update, you have some data changed, right? Therefore, you need to re-render. And these situations that you elaborate can happen in non-reactive setups, but if you have a more reactive setup like demonstrated here, it is very hard to generate that place. But even if we have a flag that you can set, and this flag is called mark parent dirty, and if you enable that flag, it is disabled by default because it would over-render. It is just used in special cases, but even for this edge case, we have a part that you can use to enable parent change detection.
Nice. And then there's some this point 17 is use rxFor in favor of ngFor to get non-blocking rendering of lists.
Yes, a very nice one. And here it is already stable and released, but let me go to GitHub RxAngular to the RFC, and I guess it is issue number 304, if I'm not mistaken. Yes, rxFor, and it is quite an old issue, September 9th, 2020, we started the research, but it is the most complete documentation of rxFor, what it can do for you, and this is like all the flaws that the normal ngFor will introduce in your code base. And you have also, while you destructed a lot of stuff, the solution is chunking up the work in pieces and be always interactive. This is a demo of a huge component tree that is rendered, and you see it is rendered step by step. We introduced a lot of different optimizations, concepts, features. You see that this is was quite a challenge. Also, error handling is done. And here we have the comparison measurement. This is before, this is after. And here you see it as an image. So this was the demo list that had 5 by 10 items, and running the ngFor within it with some clicks and with an interval looks like this. And if you run the rxFor with an init, some clicks and an interval, it looks like this. And it is quite a difference if you just look on the interval, on the heavy interaction here, not a single blocking task. And also here and here, it is nearly noiseless in the flame. So that's a dramatic improvement that you can achieve with this implementation.
So basically, everybody who's watching this, they should immediately go and do a find and replace on ngFor and rename it to rxFor.
You could try it. I mean, we have a PR that ships it at stable. At the moment, it is in the experimental path. But I would be slow with just find and replacing. I would first try the impact, see what priority you want to use, because you can also use different priorities, and then I would go on and use it on places where I need it, right? Don't over-engineer your app where it is not needed.
Mm-hmm. And then the last one is avoid host listener on the document, as it would add an event listener on component bootstrap, no matter if we need it or not.
Yeah, so this is related to using host listeners that basically fire whenever the component bootstraps, and you have it all the time. So if you have a drag and drop, what you don't want to do is you want to have listen to mouse move events, even if you don't click down and like mark something as draggable. You click, drag, release, and the real process should be you click, then you listen to mouse movements as long as you release at some point, and this way you save a lot of change detection cycles. I would also say avoid host listeners wherever you can, and use RxJS instead of it, because it is lazy. It will only create the event listener when you really, really needed. And this is the way to go, I guess, for anything that is more fancy than just a key down listener.
Yeah, I remember an app where I had this. I couldn't figure out why it was running change detections all the time. It was something like a host is now in the document somewhere that is just we're triggering change detection all the time. All right, that was the 18 points. Maybe you can talk a little bit more of the scheduler. Sounds interesting with RxAngular. How if people want to start using RxAngular now after watching this episode, like how should they set up the scheduler? Do you have any tips on what like newbies
I
should
can
do?
tell you. You don't need to think about the scheduling. It will work out of the box, and what you should look at is the strategies. But I can give you a lot of information here, and more technical if you like. And I guess this will be a good roundup of the whole thing here. Concurrent strategies is the set of strategies that we provide, and we talk about frame drops, long tasks, what they are, and we elaborated a little bit and why they are like not really good. We explain in detail what is a long task, why it is measured as a long task, and then we talk about the techniques that we use, scheduling, UI interaction, and why it is really important to have earlier interaction. Like there is a new API even that is called INP, Input to Next Paint. And it tells you how interactive your page is. There's also the responsiveness as API that will land. Some scheduling mechanisms in general that are out there. And then the concept that you can prioritize with scheduling is also very important. You can like down prioritize work and push it like because idle callback, for example, send it as a later point in time. And then we have chunk up work, and this is, I guess, the most interesting stuff where we really build up notion of the frame budget. We say we know how long it can work, and all this is then together, prioritization, cancellation, scheduling, the deadline, chunking, and the frame budget, called concurrent scheduling, because you can have a lot of work concurrently. This image is already known, right? So we know that what we do is we chunk up the work in different pieces instead of doing everything at once. And there is some more anatomy. So we have the frame budget, we have work here, we have a task, the render deadline. And down here, we also elaborate how it is done. Like first we schedule everything, then we sort, prioritize everything, and then we execute everything. Or the scheduling APIs, like the priorities that relate to different user inputs. And this is more or less, I would say, the essence of the strategies. I have some examples, of course, for all that things, but in general, if you read the top section here, you should get a really technical detail on what they do under the hood. But by using them, you just use rxlet, rxFor, rxif, and you are done. No technical knowledge needed.
It will work fine just with the zero config and the defaults.
Yeah.
Nice. Yeah, I think the last question I have is if you should pick like one of these performance techniques we talked about, which one do you think would give the best bang for the buck?
For what problem?
Yeah, let's say we have a web shop that is slow, and yeah, you wanna speed it up.
You want to display the articles earlier.
Right.
Yeah, so I would definitely work with fetch priority and the images. I would preload those images. I would optimize the image quality and the image format. I would prefetch the data. If it is not by navigation, but the initial load, you can also go for server-side rendering so that everything is already in DOM here. And you can focus fully on prioritizing the requests for the images. If you say you want to have a fast, I don't know, scroll interaction on the images, I would go for more JavaScript heavy things that the rest could be done like server-side rendering and then just using HTML APIs, fetch priority and so on. But the rest could be like not render everything, or if it is an Angular application, I would suggest just introduce some rxlet, rxFor directives, they will chunk up your view automatically, and you will more or less never have a blocking task, or at least you will improve the performance quite a lot by doing that.
Yeah, that's interesting. We haven't talked too much about server-side rendering here, and it's normally, I think, people start introducing it, if they load slow, they're thinking, oh, if I just server-side render, then all the HTML is pre-rendered, and then it's going to be faster. But actually, usually what happens when once you start introducing it, actually you drive up the times for interactive, because not only are you rendering the server bundle, but also the client. And it's like, if it's not cached in any way, then it's just gonna
it is not
2x
so
or 3x the time to interactive.
Yeah.
So yeah, with Angular University, you don't really get like the same caching as you would get with, for example, Next.js, where it's like built in, it will like generate the static pages and all this. So I would say if you do that, you also need to combine it with a caching server like Redis or something, so you kind of get something, or you find some way to like statically generate if this website is a good fit for it, the pages. Otherwise, you're just gonna try up the time to interactive, because you're gonna just basically pass more JavaScript and execute both the server bundle, because it's like 2 steps now. So you need to be aware of that.
Yeah.
Nice. I think that wraps up the whole thing. Pretty good, Michael. How can people get to know more about you, and where can they find you?
I'm on Twitter, Michael_Hladky. There, I guess I'm most active. I also have a website, push-based.io, where I will ship, when I have time again, all my articles, all my documentation, and I would definitely check out my GitHub profile and the libraries that I contribute. I try to always open source the most beneficial things that I produce in GitHub, so that everybody can download it. User flows, for example, is really nice for performance. RxAngular is not only nice for performance, but also to manage component state and to have a cleaner template structure. So this is what I guess people should check out.
Awesome.
Give me a follow on Twitter is maybe the best.
Thank you very much, Michael.
Welcome.
Bye-bye. Thank you for this time.
Bye-bye.